Welcome back, folks. Another voltage divider example, and this one's going to have more than two elements, but we can still apply the voltage divider. We got to be a little careful with current dividers when we have more than two elements, and we'll see that when I introduce current dividers. But with voltage dividers, more elements in series, it's not a big deal. Okay, we can handle it without a problem. Okay, so here's a problem for you up here, and we're going to start out and just say find V out. Okay, so we're looking for the voltage across the 12 kilo ohm over here, and I've got 48 volts on the left. A lot of times we think of the voltage across the series combination as being the input, and the voltage across the individual component as being the output. Are they in series? Yeah, they're in series. We should check that, right? We want to see that the 6K is in series with the 12K, and the 12K is in series with the 18K. Look at that. They're all in series. Actually, all of these are in series with each other. Okay. And what's the other thing we want to check? Are they all in series? Are we looking for a voltage, and are we given a voltage? Okay, so we're relating this voltage across all three in series to this voltage across one of the elements that's in series. And we can do this by applying the voltage divider. Okay, so we can simply write V out is equal to, well, we look at the voltage across the series combination, and that's the thing that ends up over here outside of our brackets. That's 48 volts. Okay. And then we have a ratio of resistances. And that ratio of resistances in the denominator is going to be 6K plus 12K plus 18K. Okay, so I like that. That's a good start, and I'm even going to cut and paste it here so that I can use it again, because let's see, because the numerator is going to change. Okay, V out's across the 12K right now, so if I want to know the voltage across the 12K, that's what goes in the numerator, and we can figure that out. Let's see here. Let's grab our calculator again, and wish I could. Oh, there we go. I can make it a little bigger for you. Doesn't let me do that before. So let's say 12K. Okay, and you may look at this and go, oh, I don't need the K's. And sometimes you're going to be right, and that's going to lull you into a false sense of confidence that you can get away and do that. Make a habit of it. Put the E3 after each of those values, and that's the habit that's going to help you not screw up, and hopefully not crash an airplane or something horrible. Okay, so syntax error, great. Does that ever happen to you? What did I screw up here? Oh, 3. I missed my 3. Okay, and we get 300, and we get about a third. We get exactly a third. So we're going to get a third of 48. Okay, and that's 16. So here we're going to have 16 volts. Can I squeeze it in there? Just barely. Look at that crop. It's perfect. Right on the edge of my pad. Okay, so this is 16 volts. 12K is 1/3 of the total resistance. 16 is 1/3 of that voltage. Now, if we want to go find other voltages, I copied that, but I think I want to change the color, so we'll end up writing it again. If I want to go find the voltage across this, I didn't call it V1, V2, and V3. Maybe I should have, but I'll use different colors now. And we can say V out, if we're looking for the blue V out, everything's going to be the same. So I'm going to start off writing it the same. Okay, but the numerator is going to be different. So the denominator is the same. 6K, 12K plus 18K. Okay, but now I'm looking for the voltage across the 6K. So I'm going to get 6K in the numerator. and that's going to be, well, whatever that ends up being. Is this the fancy one? Oh yeah, look at that. This is going to get you in trouble when we do complex numbers later, but we can just move up, grab our entry, and change it so that it's 6K in the numerator. And that's going to give us 1/6 of 48, and that's going to be 8 volts. Okay, so we can come back over here and say that that's 8 volts. Let's get 8 volts here. All right. And since we've come this far, we've got to figure out this voltage. Okay, so I'll do it in red. V out equals 48 volts. That's the same. 6K plus 12K plus 18K. Hopefully you're yelling at your monitor that you already know what this is. Okay, but here's 18K in the numerator. Okay, so for the red V out, we've got 18K over there. All right, a little bit of calculator work. Grab this. Change it to 18K, so we've got to do an insert, second insert, 8, and we're going to get half, of course. So half of 48 is 24. All right, come back over here, and we've got 24 volts. Okay, so behind my head. Okay, so we can apply the voltage divider in these conditions. We want to relate one voltage to another. We know that one of the voltages is across a series combination of elements, and we want to find the voltage across one of those elements. Okay, so we're not always working in this direction. Sometimes we have the voltage of one and we want to work back to the other. We can do that, and I'll do that in the next video. But this is pretty straightforward to apply the voltage divider when we have more than two. All we do is tack on terms in the denominator. Okay, it's easy for the voltage divider. It's not easy for the current divider. We're going to see that when we get there. Next video, I think I'm going to work one of these backwards. So I'm going to give you a voltage across an individual resistor, and we'll go find the source voltage that you need to make that voltage happen. Okay, so stay tuned and good luck.